We need to take 1000 minus. So we get 700. Who talking? Oh, okay, Aloysius. What is the 60th percentile? I don't know. You talking. What is the 60th percentile? 1, 3, 7. So where is the 60th percentile? Find the position first. 60th percentile position. Okay, good. Position is equal to 600. Okay, so what do we do with this value of 600? Do we look at the vertical axis or the horizontal axis? Vertical. Okay, good. Find the 600 position. Draw a line across. Obviously, that's why there's a graph, isn't it? Then it touched the graph, and it comes out to 3. Okay, what is the statement that we're going to make over here? Yeah. What is the statement that we can make over here with this 600 and the 3 cm? 60% okay, you're not wrong. You're answering the question from the book. The 60th percentile is 3 cm, correct, right? But I'm asking for the interpretation of this two values, 600 and 3 cm. What is the relationship? No. Don't listen to Ziguan. Yes, Aloysius. You use the example over here. Earlier on, for this, we saw that 300 leaves are less than or equal to 2 cm. What about for the 600? How? 600 what? 600 what? No, 600 what? What are we talking about? 600 what thing? 600 leaves are less than or equal to 3 cm. Okay, so that's what it means over here. Now, to answer the question in the book, they are just asking for 60th percentile, which is what Aloysius found. It's 3 cm. That's all. Just one line, 3 cm. After you found the position, you get a value. Anybody needs Aloysius to explain why he got 60th percentile at 600? Anybody needs him to explain? No need, Okay, one of the leaves is chosen at random. What is the probability that it's more than 4 cm? So probability more than 4 cm, definitely I need to find where 4 cm is on my graph. 900, let me check. 4 cm. And we see 900, okay. So I need to form a sentence first. 900 leaves are less than or equal to 4 cm. So since the question wants more than 4 cm, how many leaves are more than 4 cm then? 900 less than or equal to 4 cm. How many are more than 4 cm? 100? Tina, do you say 100? Yeah, correct. So 100 leaves more than 4 cm. 100 leaves are more than 4 cm. Then what's the probability of choosing one of these 100 leaves? So 1000 leaves, 100 of them are more than 4 cm. So the probability more than 4 cm, correct. Probability more than 4 cm is 100 out of 1000, which is 1 over 10, yes. Alright, so this is for part B. Okay, good. Why? Wang Wei, why are you so surprised? Did you get 9 over 10? About what? Cannot be everything. I remember you were good at this one. Oh. Okay, next one. One last question. Then we are done with the workbook. Yes, then we do our 10 series already. Faisal done? Okay, last page. So this is the time spent watching TV by 200 adults. There are 200 adults, so it corresponds to this. So use the graph to find the median. Okay, to find the median, we need to first find median position. So A part 1, median position equals to? Okay, where's the median position? Okay, so I'll prefer you to write as 50% or 50 over 100 lah. 50 over 100 times 200. That is half of 200. So we get 100. That's the median position. So here is our median position. So what is the time? Wow. What do you all see? 15, 16, 17? Is it 17? Because I cannot see clearly. Okay, so part A, part 1, median, 17 hours. Just find the middle and find the corresponding time. Then now for the interquartile range, part 2. Let's find the lower quartile position first. Position. So that will be 25 over 100, which is 1 over 4 times 200. We get 50. Okay, so the lower quartile position is over here. Wow, is that 12? So the lower quartile equals 12 hours. And we need the upper quartile position. Okay, wait in. What is the upper quartile position? How is it found? How do we find the upper quartile position? You don't have to look at the book. How? Okay, 75 over 100. Now you need to look at the book times what? How much? 200. So we get 150. So the upper quartile position is 150. And the value. Okay, good. 22.5. So upper quartile equals 22.5 hours. So with our lower quartile and our upper quartile, we can find the interquartile range. Interquartile range must be bigger minus smaller. 22.5 minus 12. So we get 10.5 hours. That's our interquartile range. You need to know the process of finding lower quartile position. Then you can find lower quartile. You need to find upper quartile position. Then you can find upper quartile. Then you can subtract and you get the interquartile range. So a few steps involved over here. That is why interquartile range is worth 2 marks. Okay, before we continue, I want you to look at what I have on the vertical axis. Can you see that this is divided into 4 equal sections, 4 equal parts? That is the whole idea of quarter. We are dividing into 4 parts. We are trying to find all the different positions. Next, part B, 30% of adults who spend more than 17 hours watching TV own 2 television sets. Use your own 2 television sets. Okay, 30% of adults who spend more than 17 hours. Okay, let me remove all these first. need to understand 30% of those adults. Which adults? Those who spend more than 17 hours watching TV. So out of those who watch more than 17 hours, we only want 30%. So let's find out how many people actually spend more than 17 hours. So we find 17 from the graph. 17 hours. Okay. So we get a statement. 100 people spend less than or equal to 17 hours. That is our statement. We need this statement. 100 people spend less than or equal to 17 hours. Less than or equal to. But the question says more than 17 hours. So how many actually spend more than 17 hours? Yeah, so 200 minus 100, we get 100 again. So 100 people spend more than 17 hours. Okay? Okay, what's happening so far? Rindiani, okay? Are you okay? So we have 100 people spend more than 17 hours. What did they say about these 100 people? 30% of them. Out of these 100 people, 30% have 2 television set. So how many people have 2 television? 30% out of 100 people. Which is? So 100% represents 100 people. We only want 30%. Yeah, 30% will then represent 30 people. So 30 people own